Okay, hello Cloud Gurus and welcome to part 2 of EC2 101. So can you still remember the different instance family types from the last lecture? If not, don't worry, just remember the overall acronym, so Dr. McGift picks. Remember that when you're going into your exams, you're going to get different scenarios and you have to pick the best instance types that would fit with that scenario. And usually 3 of those instance types will be fictitious and only 1 is a real one. But even so, going into the real world, you should really know your different family types because you will need to know these when you're architecting or developing solutions for AWS, what instance types you should be using for your applications. So in this lecture, we're going to look at EBS. So what is EBS? Well, it allows you to create storage volumes and attach them to EC2 instances. So think of EBS as disks that you attach to your virtual machines. And if you remember from S3, I kept going on and on and on about how that is object-based storage and it's not suitable for installing operating systems or databases or applications on. With EBS, this is block-based storage. So this is storage that you can install operating systems on, that you can install databases on, that you can install your applications on. And so once attached to your EC2 instances, you can create a file system on top of these volumes, you can run a database, or you can use them in any other way that would use a block device. Amazon EBS volumes are placed in a specific availability zone where they are automatically replicated to protect you from the failure of a single component. And by single component, really, they're just talking about storage arrays. So if the storage array goes down, there is a backup storage array, so your EBS volume will stay online. Note though that these are not automatically replicated to different availability zones. They stay within the availability zone, but they're just not dependent on one physical device. So if a storage, if SAN goes down, doesn't actually matter because they have redundancy built in. So there are different EBS volume types, and currently there is 4, and some argue even 5 different types. So we have general purpose SSD, GP2. These are what we'll be using throughout the rest of this course. So they're general purpose, they balance both price and performance. They are SSD, so you get really good performance from them. You get 3 IOPS per gig. So if you provision an instance, or if you provision a disk that only has 1 gig, you're going to get 3 IOPS. If you provision a disk that's going to have 100 gigs, you're going to get 300 IOPS, etc. And you can go up to 10,000 IOPS, and you have the ability to burst up to 3,000 IOPS for extended periods of times for volumes under 1 gig. So these are really, really great disks, and this is general purpose. This is the ones that you use the most often. We then have provisioned IOPS SSD. These are called IO1s, and we'll see these different tags later on in this section of the course. These are designed for IO-intensive applications such as large relational databases or NoSQL databases, and you would typically start to use this if you need over 10,000 IOPS. So that's really a good litmus test. If your application is going to be using less than 10,000 IOPS, you're going to want general purpose SSD. If you're going to be going over it, if you've got really, really big database servers, for example, you're going to want provisioned IOPS SSD. And then with provisioned IOPS SSD, you can actually go up to 20,000 IOPS per volume now. So they are really, really super fast. Moving on to magnetic storage. So in the previous slide, we were talking about SSD. We're now talking about magnetic storage, and these are your old school physical, spinning disks. So we've got throughput optimized hard disk drive, and this is known as ST1. This is typically used for things like big data, data warehouses, log processing, etc. It's where you've got large amounts of sequential data. So that's data that's written in sequence as opposed to data that's insequential, where it's spread all over the disk. This is where it's written in sequence, and they basically optimize the throughput for these devices. So again, these would be used for big data, data warehousing, log processing, etc. Now, the key thing to note about throughput optimized hard disk drives is they can't be boot volumes. You can't boot from these particular drives, and we'll see that in the very next lab when we provision our first EC2 EC2 instance. We then have cold hard disk drives. These are known as SC1s. These are the very lowest cost storage for infrequently accessed workloads. Typical use case for this is a file server, and maybe you don't access the files at all. Maybe you don't want to put it on S3 for whatever reason. Maybe you need to, your application needs to be able to read from it in a local device. So this is where you would use SC1s. And again, these cannot be boot volumes. So we've got two SSD types, and we've got two magnetic storage devices. And then finally, we have the third magnetic storage device. This is magnetic standard. And this is the lowest cost per gigabyte of all EBS volumes that is bootable. So you can boot operating systems from this. Magnetic volumes are, again, ideal for workloads where data is accessed infrequently and applications where the lowest storage cost is important. And we're going to see this in the next lab. So we've got 5 different types, 2 SSD, 3 magnetic. Of the magnetic, you've got high throughput, and then you've just got what's called cold storage. The high throughput and cold storage cannot be bootable. And then if you do need bootable, it's called magnetic standard. And this is why I said some argue that there's 4 different types of EBS volumes. Some argue that there's 5. Your magnetic standard is basically your cold hard disk drive, except one is bootable and one's not. It's all the same, basically, disks. So let's talk about what we're going to cover in the rest of this section of the course. So we're going to learn how to launch an EC2 instance. We're going to start learning about security groups, which are basically like virtual firewalls. We're going to learn about volumes and snapshots. We're going to learn how to create an Amazon machine image, or AMI. We're going to learn about load balancers and health checks. We're going to learn about CloudWatch, how we can monitor what's going on with our EC2 instances. And then we're also going to learn about the AWS command line. We're going to run these on our EC2 instances, but you can also run the AWS command line on your laptop or on your desktop PC, and you can start interacting with the AWS platform via that mechanism. We then are going to learn about IAM roles with EC2. Now, when we did our IAM lab, right at the very end, we created an EC2 role, which I said we were going to use later. So we are going to use it in this section of the course. We're going to learn about Bootstrap scripts. They're really, really cool, and you're going to get addicted to writing Bootstrap scripts. So I'm going to show you how to do that. We're going to learn about launch configuration groups, and then how to use auto-scaling. And auto-scaling is one of the most powerful parts of EC2. It was literally a game changer. Again, I say EC2 changed cloud. Also, auto-scaling changed the way cloud providers provisioned virtual machines. Auto-scaling used to be just Amazon only, Amazon proprietary technology, and it really differentiated Amazon from other cloud providers. So we're going to learn how to do auto-scaling. And then we're going to learn about elastic file system. This is where you can have shared storage between different EC2 instances. So we're going to learn about that. And then we're going to learn about Lambda. We're going to do a brief overview because Lambda does not yet feature in any of the associate exams. I'm sure that will change though, because it is one of the fundamental pieces of AWS right now. Lambda came out in 2014 at reInvent, and it completely, again, has changed the world. And we're going to have a bonus lab in this section of the course where we're going to create our own Alexa skill, which uses Lambda. You don't need an Alexa device to do this. We're going to just log into the developer portal and interact with Lambda using a GUI that they've got. Again, with this particular lab, it has nothing to do with the exam. It's completely optional, but I just want you to get some hands-on experience with Lambda in a fun way so you can understand what it is and how it works. We're then going to move on to high-performance compute and placement groups and just learn at a theoretical level as to what they are. And then we're going to round up with a summary of every single thing we've learned in the EC2 section of the course. So you've gotten through the intro, you've gotten through the 101 lecture, congratulations. So what are my exam tips so far? What should you remember from the last 2 lectures? Well, you should know the differences between the different pricing models. So know the differences between on-demand, spot, reserved, and dedicated hosts. You definitely need to know that going into the exam because you're going to get a whole bunch of different scenario questions, and then you're going to ask you, based on this scenario, what pricing model should you use for this EC2 instance. You should also remember with spot instances that if you terminate the instance, you're going to pay for that hour. So if you're half an hour in and you no longer need that spot instance and you terminate it, you're going to pay for a 1 hour's worth of EC2 time. However, if AWS terminates the spot instance because the spot price has gone above the bid price, so the spot price has gone above what you're willing to pay, you're going to get the hour in which it was terminated for free. And again, it's really important that you remember those two different models with spot instances, because again, you're going to get different scenarios, and they're going to ask you as to how much compute time that you pay for. And then finally, moving on to EBS. So what does EBS consist of? Well, it's SSD general purpose. So this is for anything up to 10,000 IOPS. We then have SSD provisioned IOPS, which is IO1, and this is for anything more than 10,000 IOPS, and you can have up to 20,000 IOPS per volume with provisioned IOPS now. We then have HDD. This is throughput optimized storage. So this is magnetic storage. Again, this is for things that are written in sequence or sequential writes. So this is things like big data, things like logs. This is things like data warehousing, etc. And then we have HDD cold, and this is for less frequently accessed data. Neither of these two magnetic volumes can be bootable. So HDD cold is typically used for file servers, for example. And then we have HDD magnetic, and this is bootable, and it's basically the cheapest bootable magnetic storage that you're going to get. So remember the 5 different types. Typically, mostly you're just going to be using SSD. You might be using magnetic storage, depending on if you're running data warehouses or file servers, etc. Or you might just want to be keeping your costs low when you're experimenting with AWS, and you might not have any need for SSD. But SSD does fall, or certainly SSD general purpose falls within free tier anyway, so you do get a certain amount of SSD storage per month for free anyway. Now, a really important point to remember going into the exam is that you cannot mount one EBS volume to multiple EC2 instances. So if you think of an EBS volume as an internal hard disk that's plugged into your laptop or into your desktop, for example, you can't then connect another laptop or desktop up to that internal hard disk while your computer's on running at the same time, right? It just doesn't work. So likewise, you cannot mount an EBS volume to multiple EC2 instances at once. If you need some kind of shared storage area, you're going to need to use EFS, and we're going to have a lab on that coming up as well. And then finally, we have our different EC2 instance types. So can you remember what this stood for? So he's Scottish, he's a doctor because he's got glasses on. I don't know, maybe you should have a stethoscope. I'm not a graphic artist, so I'm not going to edit this too much. But he is a doctor. Because he's Scottish, his name begins with Mc, but instead of it being McDonald's, where he sells burgers, he actually gives pictures of Scotland. He gives them away, so it's Dr. McGift Pics. And again, I know it's a horrible acronym, but Amazon is starting, there's 10 letters now, and there's only one vowel. If you can come up with something better, I'll re-record this entire last 2 lectures for something better. But if you can just remember Dr. McGift Pics and try and remember what each letter actually stands for and what the actual use case is, you'll be much better placed, certainly when architecting or developing for AWS in the real world, but it'll also help you in the exams because you'll be able to identify bogus EC2 instance types in different questions. And like I said, it's not too important in the developer associate and the solutions architect associate exam. Where it really does come up is in all the other exams. So SysOps administrator associate, both professional exams and in the specialty exams as well, you are expected to know the different instance types. So that's it for this lecture, guys. You've done really well. Now the rest of this section of the course is going to be very, very hands-on. There's only 1 or 2 theoretical lectures moving forward. So in the very next lecture, we're going to really start getting our hands dirty, and we're going to start spinning up our first EC2 instance. So if you've got the time, join me in the next lecture. Thank you.